In this lecture, we're going to discuss section 8.2 that talks about the graph of other trig functions. So previously we looked at the graph of sine and cosine. In this section, we're going to look at the graphs of tan, cotangent, secant, and cosecant. So the graph of tan, recall that tan is sine over cosine. So when we're doing the graph of tan, just like when we folded out the unit circle for sine and cosine, we're going to do the same thing, but keeping in mind that the graph of, or that tan is equal to sine over cosine. So if you notice, well, we cannot divide by 0. So what that means is we're going to have vertical asymptotes wherever cosine is equal to 0. So that's going to be at pi over 2 and increments of pi over 2. So that would be pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth, and also in a negative direction. So here you notice on the red lines that we have a vertical asymptote at pi over 2, and so on. Okay, but this is basically what the graph of sine looks like. Tan looks like. So to come up with some of the characteristics similarly to what we did for sine and cosine, there's a stretch factor of a. So usually a was your amplitude. There's no amplitude for the graph of tan. The period is going to be pi over b. The domain is going to be all x values except for those values that are equal to c over b plus pi over 2bk. The vertical asymptotes occur at, well, to find your vertical asymptote, you're going to set whatever is in your parentheses equal to k pi plus pi over 2, where k is an odd integer. And basically, you're going to solve for x. So recall that when we're talking about a vertical asymptote, we're looking for an equation of a line, okay? And so in this case, x will be equal to whatever we solve and get for that equation. So looking at an example, so let's say you want to sketch the graph of y equals 0.5 tan of pi over 2x. So first, let's identify our a. So our a is going to be 0.5, and also our b is going to be pi over 2, right? Now, our period is going to be pi divided by b, which is pi over 2. Keep, change, flip gives us 2 for our period. Sometimes you want to evaluate a function at a point to kind of see where the graph is going to be. So we can evaluate it at 0.5. So that would be 0.5 tan pi over 2 times 0.5. And if you plug this in your calculator, you'll get that this is equal to 0.5. So this graph is going to pass through the point 0.5, 0.5. Okay, we can also find other points. If you plug in 0 for tan, for x, then you'll get the point 0, 0. And you can keep going. It's really up to you. Alrighty, so now the last thing that we need to find, which is very important, are the vertical asymptotes. And so to find the vertical asymptote, remember we're going to set whatever is in our parentheses. So that's going to be pi over 2x. We're going to set that equal to k pi plus pi over 2. So we're using this here. And so what we're needing to find is what is x, because recall, a vertical asymptote is going to be in the form x equals. So if I want to solve for x, well, I can multiply both sides by 2 divided by pi, the reciprocal of pi over 2. This would cancel, so I'll have x equals, this would be, the pi would cancel here, so this would just be 2k plus 1. So I'm multiplying each of these. Now, after you found what x is equal to, recall that we said that k is going to be some odd integer, so 1, 3, 5, and so on. So here we can plug in different values for k. What I'm going to use are, let's say, k equals -1. Well, if k is -1, then we'll have 2 times -1 plus 1, which would give us -1. So that means here x is -1 would be my asymptote. If k equals 0, then that means x equals 1 is my asymptote. So we'll just use these two to kind of sketch the graph. So we know that there's going to be an asymptote at x equals 1. So we'll put that there. And then another one at x equals -1. Okay, we know the graph is going to go through the point 0, 5, 0.5, 0.5. So say that's here. And that will be here, as well as 0, 0. That's negative, actually. Oops. Point five is actually here. So the graph would look something like that. So that's how you would graph this function here. All right, let's look at another example. Let's say we want to graph -2 tan of pi x plus pi. So here we can again highlight what is a, b, and so forth. Of course, a, really we should be doing the absolute value of a. That's going to be 2. This is my stretch. We can also look at my b, which helps me to determine my period. So my b here is pi. And this means the period is going to be pi over pi, because it's pi over b, right? This is going to be 1. Now, very important, if we're thinking about the phase shift. So your phase shift is c divided by b. But remember, the original graph of tan is y equals a tan of bx, very important, minus c, right? So in this instance here, we have a plus. So we know that we could rewrite this as pi x minus negative pi in order to get it to look like this. So what this means is my b is not just pi. Oh, no, my b is pi, sorry. my C rather, is negative pi, and my B is pi. So that means this phase shift is going to be -1. Now to find my vertical asymptote. So again, what we're going to do, we're going to set this whole thing, pi x plus pi. We're going to set this equal to a pi plus pi over 2. And so, again, we're solving for x. So the first thing I'm going to do is subtract pi from both sides. So this is going to be pi x equals k pi. Pi over 2 minus pi, it's like 1 minus 1/2. That's going to be, it's going to be like 1/2 minus 1. It's going to be negative pi over 2. Okay. And then we divide both sides by pi. Or you can look at it as though we are multiplying both sides by 1 over pi. So this goes away for each, because I'm multiplying each term by 1 over pi. And so this becomes k minus 1/2. So that's what x is equal to. Now, recall k can be any constant that's odd. And so let k be 1. That means we have x equals 1 minus 1/2, which is negative 1/2. Let k be 3. We can let k be 0 as well. Now this is a positive 1/2. We can let k be equal to 0. That means x equals negative 1/2. And if we let k be negative 1, then x is going to be equal to negative 1 minus 1/2, which is negative 3/2. So again, we're going to draw our asymptotes in first. So we're going to be at 1/2. Let this be 1. 1/2 would be about here. Well, actually, I could just let this be 1/2. Uh, 1/2, negative 1/2, and negative 3/2. Okay, so these are my vertical asymptote. X equals all of this. And so what you also want to note is that this is a -2, which means we're going to have a reflection about the x-axis. So instead of this being, look at the regular tan, it's actually going to be flipped and look like this. Okay, we can also plot some points here. If you plug in -1, if you plug in -1 for x, and you can always evaluate this, you're going to get -1. I did this ahead of time. You can also try -1.25. You'll get 1. So you're just going to pick values between your asymptotes. All right, so -1, -1. going to be somewhere here. It's going to be -1. And then the other is going to be somewhere here. -1.25. 1 is going to be somewhere here. So that means my graph should look something like this. Okay. So that's the graph of this function. And it's going to repeat the same thing over and over since it's a periodic function. Okay. So now we're going to look at the graph of secant and cosecant. So secant is also has a denominator for of cosine of theta. And so what this means is we're going to also have asymptotes in those increments where cosine of theta is 0. So again, at pi/2 and at each increment of pi/2. So pi/2, 3 pi/2, 5 pi/2, and so on. Okay. And this is what the graph looks like. Really two U shapes most of the time when you graph it. Similarly to tan, you're going to have basically roughly the same things, including your vertical asymptote is going to be where you set your bx minus c equal to k pi plus pi/2. Let's look at a quick example. All right, so let's say we want to graph the function f of x equals 4 secant of pi/3x minus pi/2 plus 1. So of course, we're going to identify different things. So first thing, we know that the stretch is going to be 4. This also has no amplitude. So my stretch is equal to 4. My period, that's going to be 2 pi over b. B for me is pi/3. So it's 2 pi over pi/3, which is keep, change, flip, going to be 2 pi times 3 over pi. This goes away, so my period is going to be 6. My phase shift, that's going to be c divided by b. And in this instance, so my c is pi/2 divided by my b, which is pi/3. So that's going to be pi/2 times 3 over pi. So my phase shift is 3/2. What I want to look at now is my asymptotes. So to find my asymptotes, we're going to set what's inside of here equal to, we have pi/3x minus pi/2. That's going to be equal to k pi plus pi/2. And we solve for x. Solving for x, I'm going to add pi/2 to both sides. What does this give me? This gives me pi/3 equals k pi, actually plus pi, because pi/2 plus pi/2 is going to be pi. Then what do I need to do? I should be an x here. Okay, so now what do I need to do? Well, I will multiply by the reciprocal of this. 3 over pi on both sides. So what happens is both pi's are going to go away. So I'm going to be left with, so 3 times k is 3k plus, and this will give me a 1, so 3 times 1 is 3. And of course, I'm going to let k equal to, I don't know, 0. Then that means x is going to be 3 is my asymptote if k equals 1. So x equals 6 is my asymptote. So I'm gonna, you can also do if k is -1, x equals -3 is my asymptote. So what I'm gonna do is I'm just gonna draw these in. So 6, 0, and 3. You could also get points for this as well ahead of time. 1.5, if you plug that in, you should get 5. 1.5 is about here. 5 is about here. So my graph is going through this point. And then I can also, let's say 4.5. I'm just picking points in between. So this is 3, so 4.5 is about here. If you plug it in your calculator, you get -3. So that's going to be down here. So basically my graph looks something like this. And like this. Okay, keeping in line with the original shape of the graph. All right. Okay. So now we're going to look at the graph of cosecant. So here looks very similar to the one we just graphed, right? However, recall that cosecant is 1 over sine theta. So instead of the asymptotes being pi over 2 and its increments, it's going to be at 0 and its increments. 0, pi, 0, pi, 0, pi. I'm sorry, 0, pi, 2 pi, 3 pi, 4 pi, and so forth. All right. So for this, everything, well, your period is going to be 2 pi over b. And very important to note, your vertical asymptote, you're going to set bx minus c equal to k pi. Just k pi. And again, k is going to be your odd constants. And we have to solve for x to find our vertical asymptotes. So a quick example here. Let's say we want to graph y equals 2 CSC cosecant of pi over 2x plus 1. Okay, so basically, we can identify like we did before, a, which is going to be our stretch, which is 2. Okay. We can also identify or period. And so here the period is going to be 2 pi over b. In this case, that's going to be 2 pi, this is my b, over pi over 2, which becomes 4. My phase shift Now notice there is no c in this. So you can just say 0 divided by your pi over 2 or just 0. So this graph was not shifted horizontally, but it was shifted vertically, even though we don't really graph that. It was shifted vertically up 1 unit. Now let's find our vertical asymptotes. So of course we're going to set pi over 2x equal to k pi. And so we're going to, again, use this little trick where you multiply by 2 over pi. And so we cancel these here. So you'll have that x equals 2k. Again, k is your odd number. So if x equals 2k, well, I can plug in 1 for k. That means x equals 2. I can plug in 0. That means x equals 0 is also an asymptote. I could plug in, yeah, let's just use these. Okay, so zero is an asymptote, and 2. Well, let's put in -1. Let's do the other side. And -2 will be that means x equals -2. So if you recall, we're going to be up 1 unit. So it's going to be about here and here. So these are just sketches of the graph. The most important thing is to know how to identify your stretch, period, phase shift, and vertical asymptote. Of course, if the graph is shifted up or down vertically. The last graph we're going to look at is the graph of cotangent. And the graph of cotangent, just like the graph of cosecant, the denominator is sine. I'm sorry, just the graph of tan. The denominator is sine. And so not tan, I said correctly. Just like the graph of cosecant, the denominator is going to be sine. So at increments of 0, pi, 2 pi, and so on, you're going to have your vertical asymptotes. So of course, everything is roughly the same, except, well, no, yeah, mostly the same for your secant graph here. Actually, this is supposed to be cotangent. Here we go. And so, yeah, when you're doing your vertical asymptote, it's the exact same thing. You're going to set whatever is in this parentheses here equal to k pi. So, of course, let's go through and figure out each of our little components. Our stretch, that's going to be 4. My b, that's pi over 8. So that tells me that my period, excuse me, that tells me that my period is going to be pi over b, or 8. My phase shift well, that's b over c, or c over b rather. So that's going to be pi over 2 over pi over 8, or pi over 2 times 8 over pi, which is 4. My asymptotes, okay. So we're going to do pi over 8 x minus pi over 2 is equal to k pi. So I'm going to add pi over 2 to both sides. And so this becomes pi over 8x equals k pi plus pi over 2. So that means x, so of course, I'm going to use a trick of multiplying by the reciprocal on both sides. So these cross out, cancel out. So that means x is going to be, the pi's go away, and then I multiply each side by 8. So that's going to be 8k. This is going to be 2 plus 4. So if the vertical asymptotes are found at 8k plus 4, I'm going to let k be equal to 0. Then that means x equals 4 is one of my asymptotes. If I let k equal 1, that means x equals 12 is also one of my asymptotes. What we want to also note is different points that this will go through. If we let x be 6, then this point is going to go through 6, 2. If we let x be 10, this point is going to go through 10, negative 6. And again, these points, I'm just plugging in different values for x into the function, and you can plug it straight into your calculator. So I have vertical asymptote at 4 and 12. Okay, so we have a big stretch. So we're going to go through the point 6, 2, and 10, negative 6. So somewhere down here. So somewhere here, something like this. Let me try again. All right, so we're at 6, 2, and 10, negative 6. So as I said, it's going to be quite a stretch. And that's our graph. All right. So that's our lecture for today. Be sure to do your homework and keep up the awesome job, guys. Have a great day.